welcome to Mrs. Bibb's Algebra 2 class, first 9 weeks, week 3. Please make sure to fill in your table of contents using your document that you've been provided. Once you do that, if you'll please make sure to complete your warm-up on a piece of paper. Label that warm-up page 12. Then check your warm-up when you're finished. Here's the document from last week that I used. So if you'll get out page 7 and we'll look at this. What I want you to do is take the time right now, after I finish giving you direction, I want you to, in this second blank of each of these, I want you to fill in the transformation that you see from the pink parent function to the black transform function. For example, we'll do the first one together. To go from the parent function, which you should have graphed on your paper in whatever color that you did, to go from the parent function to the black transform function, I believe, if my sight doesn't fail me, I believe that you've gone down 3 units. 3 units, yes. Go down 3 units. So you'll put down 3. We'll do the next one together as well. To go from the pink parent function to the transform function, that looks like left 1 unit to me. Let's get a closer look. Nope, left 2 units. So if you'll pause your video now and go through, analyze those transformations, and write them in the second blank on number 3 through number 20. I have gone through and placed in each of the second blank the answer for the transformation from the pink parent function to the black transformed function. I did have to get the document that has these original graphs on it and make it large. I made it 210% so that I could see the actual transformation. So these are accurate. If you are off a number or two, that's okay. Just erase what you have and replace it with the correct answer. I did see that these are the correct numbers that you'll see on these transformations if you could zoom in. Okay, so if you'll check these, number 1 down 3, we did this one together. Number 2 left 2. Number 3 down 3. Number 4 left 2. Number 5 right 5. Number 6 down 5. One thing that I did was I counted from one of the points that I knew that I plotted to a point that would have been on that same graph. I counted from here to here, and from this 0, 1 point down to here, from 1, 1 over to here, and from 0, 0 right to here, and from 0, 2 down to here. So that's how I got those numbers. Let's check the next group. Number 7 left 1. Number 8 up 3. Number 9 down 4. Number 10 left 2. 11 up 2. 12 down 3. 13 up 1. 14 up 5. And 15 right 3. I need to mention that on number 8, I have graphed the parent function incorrectly. So if you'll please fix yours, I don't know, I guess I just did not see the correct number. So if you'll please fix yours and graph that parent function correctly. My pencil is the parent function. We'll continue and check the final ones on the bottom of my paper. Number 16 up 3. 17, the parent function did not move anywhere except become more narrow. And that is a vertical stretch. How did I figure out a vertical stretch of 2? Well, on the parent function, we went from 1, 1 to 1, 2. The y-coordinate was multiplied by 2. And we went from negative 1, 1 to negative 1, 2. The y-coordinate was multiplied by 2. So that's how I knew I had a vertical stretch of 2. A vertical shrink would have been wider. A vertical stretch is more narrow. So that's how you tell the difference between a vertical stretch and a vertical shrink on a graph. For 18, write 1. How did I know that 18 was not a stretch or a shrink? Because when you look at the problems, you've got 1, 1, negative 1, 1. They are in the correct proportion with one another. 19, down 3, 20, left 2. If you'll notice, I have gone through and written the equation for the parent function. This would help you to answer the next final blank for this page. You're going to need page 6. You're going to need this page. It will help you be able to write the correct equation for each of the transform functions. That's what we're going to do. So if you will please go through and write the parent function for each of the problems, then I want you to attempt to write the equation. I'll do the first two with you. When I look at number 1, I want to take y equals x squared and move it down 3. Okay, so down 3. Here's the word down. So I want to translate down. Down means it goes on the outside, and that was a quadratic, yes. So that was a quadratic. Here's a quadratic. To move it down 3, down k units, I put minus 3. So that's what I'm going to put for number 1. I'm going to put y equals x squared minus 3. That's the equation for this transform graph. Let's look at number 2. It says left 2. Okay, that's a horizontal transformation. A horizontal transformation goes on the inside. Horizontal is left or right. And we have absolute value, so ours is going to look something like this. You put plus h if you're going left and minus h if you're going right. So let's look at what we have. We have left 2. So being a horizontal transformation, it goes inside with x. Y equals, we're going to have absolute value. X is going to be on the inside, and left 2 is going to be inside with x. And remember, on the inside, it's the opposite. Normally left 2 we think as minus 2, but it's going to be plus 2. So there's the equation for that black transformed graph. So if you will attempt to do 3 through 20, we'll come back and check the answers together. I completed 3 through 20. Number 3 says to move the parent function down 3. Down is a vertical movement, so that's outside of x. It would not be, the minus 3 would not be in the exponent with x. It would be outside, so y equals 2 to the x, subtract 3. Number 4, left 2 is a horizontal movement. Therefore, it needs to be inside, or it needs to be with x. X is in the denominator, so the 2 that I'm going to use needs to be in the denominator with x. The incorrect answer that some students would put would be this. That is incorrect, so make sure you do not use that. Since it's left 2, the 2 needs to be with x in the denominator, and since it's a horizontal movement, it's the opposite, so plus 2, x plus 2. Right 5 is a horizontal movement. Therefore, 5 needs to be inside with x, inside the absolute value, and it needs to be the opposite, so minus 5. The constant function is relatively easy because if you're going to move 2, y equals 2, down 5, then it's going to be negative 3. 2 minus 5 is negative 3. Moving on to number 7. left 1, that's a horizontal movement. So my 1 needs to be inside with x, plus 1. Make sure your square root top goes all the way over the x plus 1. Up 3 is a vertical movement. Plus 3 will be outside of x. Down 4, that's a vertical movement. So minus 4 needs to be outside of x. It would be incorrect to continue your square root symbol all the way across the minus 4. It has to stop here and the minus 4 be outside. Number 10, left 2. Left is a horizontal movement. I need to point out as I'm writing this that I chose to write f of x this time instead of y. They mean the same thing. So that's my function notation, y equals the square root of x, or f of x equals the square root of x. Left 2 is a horizontal movement, so inside with x, I'll put plus 2. Up 2 is a vertical movement, so that means outside of the square root of x, I'll put plus 2. Notice I stopped that square root. Down 3 is a vertical movement, so f of x equals, I will not put parentheses around the x squared because we're talking about vertical, outside away from x, minus 3. Up 1 is a vertical movement, so that's why I have 2 to the x plus 1. Up 5, a vertical movement. Right 3, horizontal movement, inside with x, and the opposite, minus 3. Moving on to number 16, I have up 3. So I took my constant up 3, 2 plus 3 is 5. This one here was that vertical stretch. Remember, a vertical stretch is when you multiply by 2, multiply the outside by 2, so 2 times x squared. That's the vertical stretch. Right 1 for number 18. Horizontal movement, inside with x, the opposite, minus 1. Down 3, vertical movement, down 3. So that's why I have minus 3. Vertical movement, outside of x. Left 2, horizontal movement, inside with x, and plus